Hey guys, this is Miss Adams, and we're going to move on to our Unit 3 material for this Algebra 1 2022-2023 midterm review. So Unit 3 really focuses on systems of linear equations. So the first question asks us to graph the system and then identify the solution. Let's graph this first line, y equals negative 3x plus 5. My starting point is going to be the y-intercept of 5. Then I'm going to go down 3 and to the right 1. Or I can go up 3 and to the left 1. And then my next equation is y equals 2x minus 5. So I'm going to start at negative 5 and go up 2 to the right 1. Or I can go down 2 to the left 1. And my solution is going to be where these intersect. So my intersecting point here is at 2, negative 1. Now let's solve these, because there's a few ways that we can solve systems of linear equations. We can solve by graphing, we can solve by substitution, and we can also solve by elimination. So if I want to solve by substitution, I've got y equals negative 5x minus 1 and x equals 2y minus 9. Both of these are already solved for a single variable. So I'm going to replace negative 5x minus 1, and I'm going to substitute it in for y in that second equation. So I have x equals 2 times negative 5x minus 1 minus 9. I then need to distribute the 2, which will give me that x is equal to negative 10x minus 2 minus 9. Negative 2 minus 9 is going to give me that x is equal to negative 10x minus 11. Then I'm going to add that 10x to both sides to give me 11x is equal to a negative 11. And finally, I need to solve for x by dividing by 11. So x is equal to negative 1. I'm going to take this value of negative 1 and plug it into my first equation. So I've got y equals negative 5 times negative 1 minus 1. So y is equal to 5 minus 1, which gives me that y is equal to 4. So my solution is negative 1 comma 4. For number 3, I'm going to solve it the same way. I've got 2x minus 3y is equal to 16. And x equals 3y plus 2. In this case, only one of these equations is solved for a single variable. So I'm going to take that x equals 3y plus 2. I'm taking that 3y plus 2, and I'm going to substitute it in for the value of x in the first equation. So I have 2 times 3y minus 2 minus 3y is equal to 16. I'm going to distribute the 2. So that gives me 6y minus 4 minus 3y is equal to 16. Combining like terms, that gives me that 3y minus 4 is equal to 16. I'm going to now add 4 to both sides. And that's going to give me that 3y is equal to 20. See here. Oh, that's my fault, guys. I apologize for that. I wrote this the wrong way. This should have been a positive 2. I knew something wasn't adding up right. So this should have been a positive 4. So I need to subtract 4 on each side here. So that gives me that 3y is equal to 12 now. Divide by 3 on both sides. Y is equal to 4. I then can plug that into the second equation. So I have x is equal to 3 times 4 plus 2. So x equals 12 plus 2, giving us an x value equal to 14. So my solution here is 14 comma 4. Let's go on to the next page. So number 4 is an application with our systems of linear equations. So in this case, I need to write and solve this system. So Mr. Sakita is taking your class on a field trip to the aquarium that charges $4 for adults and $2 for students. A total of 27 tickets were purchased for the field trip at a total cost of $60. How many adult tickets and how many student tickets were purchased? So my two unknowns are the amount of adult tickets and the amount of student tickets. I'm going to say that A is the number of adult tickets, and that S is the amount of student tickets. Now, the first thing it tells me is that 27 tickets total were purchased. I know that they were adult and student tickets. I just don't know how much of each. So I can say that A plus S, so that's the adult tickets plus the student tickets, equals a total of 27 tickets. I also know that the total cost for this trip was $60. But I know that each adult ticket was $4, so that's 4 times the adult tickets. And that each student ticket costs $2, so that's 2 times the student tickets. We've now got 2 equations, and we can solve this system of linear equations. So I've got A plus S is equal to 27, and 4A plus 2S is equal to 60. Right now, I don't have a single equation solved for a variable. So for this first equation, I'm just going to go ahead and solve it for S by subtracting an A on both sides. So now I've got S is equal to 27 minus A. I'm going to take this 27 minus A and substitute it in for S on the second equation. So I have 4A plus 2 times 27 minus A is equal to 60. I'm going to distribute the 2 to give me 4A plus 54 minus 2A is equal to 60. Combined like terms gives me 2A plus 54 equals 60. I'm now going to subtract the 54 from both sides. So that gives me that 2A is equal to 6 and divide by 2. So the amount of adult tickets is 3. I then can replace this on the left-hand side to give me that S is equal to 27 minus 3. So the amount of student tickets should be 24 tickets. For elimination, our goal here is to eliminate a variable. And if I'm looking at these 4 options, the only one that really makes sense is I know I need to change a sign somewhere because right now all of my variables have a positive sign. So B is the only one that makes sense. But I can double check that. If I multiply that first equation by a negative 2, that's going to give me a negative 8x minus 18y is equal to negative 8. And now my y values are eliminated. Number 6, we're going to then, again, we're looking at graphing or solving by graphing. And in order to do so, we're going to break this down a little bit more than what we did with the first one. We're going to identify our slope and y-intercepts. This first equation is already in slope-intercept form. My slope is 3 over 1, and my y-intercept for this equation is 0, 2. So I start at 2, I go up 3 to the right 1, or I can go down 3 to the left 1. But my second equation is not in slope-intercept form. So I'm going to have to subtract a 2x from both sides to get y equals negative 2x plus 12. I now have a negative 2 over 1 slope and a y-intercept at 0, 12. Unfortunately, 0, 12 goes off the chart just a little bit, but I know I need to go down 2 into the right 1 for this slope. And by doing so, I do find an intersection point, and my intersection point here is at 2, 8. This leads us to the last problem in our Unit 3 material. And we're going to be looking at writing the equations for the following systems of equations. So our first equation, I know that it has a y-intercept at 0, 2. And it has a slope of -1 over 1. So that equation is going to be y equals -1x plus 2. The second equation has a y-intercept at 0, -4. But it has a positive 1 over 1 slope. So I could write this as 1x minus 4. And guys, that's all of the material from our solving systems of linear equations.